Thank you so much for the opportunity to present. My name is Anobel Odisho. I'm a urologic oncologist. I'm also board certified in clinical informatics, which is what led me here. Just some disclosures to present. And we're going to talk a little bit about artificial intelligence and digital health in medicine and sexual medicine. Now, we hear this term thrown about everywhere, oftentimes by people who probably couldn't even spell AI a few years ago, but it's being put everywhere, and I love this quote, it's tech's meaningless equivalent of all natural, just like these Cheetos are all natural. There's a few different variations of AI, different flavors, different levels of complexity. First, we have strong AI or artificial general intelligence. That's the kind of sci-fi agent world. We're going to spend most of our time talking about weak AI and narrow AI. Weak AI being a machine that's running a program that is basically simulating human behavior, and narrow AI, which is an algorithm that's optimized to perform a very specific, narrow, clearly defined task in a specific context that can be measured against some objective finding. And this quote from former Google CEO Eric Schmidt was that AI systems are dynamic, emergent, still learning, and imprecise, and we have to keep that in mind. Now, when we talk about AI, what really brought this more to our attention, obviously AI research has been going on for the past 50 years, was large language models and this real boom in interest. Now, there's been an arms race in the size of these large language models. On the y-axis here, you see the number of parameters in billions, and it's a logarithmic scale. And the most recent, the earlier models were 100 million parameters. The thought is that GPT-4, that some of you may have heard of, it's about 1.8 trillion parameters. These models used to take a weekend to train. GPT-4 is rumored to have taken 25,000 GPUs, processing units. Each one of them costs about $30,000, about $750 million just of GPUs running for about 100 days to train the model. But they're also coming down in size, and that's really critically important. There's certain models that are now really effective at 8 billion parameters, 3 billion parameters. What that means is those are running on your phone, on your laptop, everywhere. There's been such a massive investment just between these four companies, Amazon, Microsoft, Alphabet, and Meta. They're expected to spend about $190 billion in CapEx over 2024. And these things take up so much energy that actually Microsoft has invested in reopening a reactor at 3 Mile Island, and Amazon and Google are also investing in nuclear reactors because these take so much power. But as they're getting more expensive to train, they're actually getting easier to use. They're very simple web interfaces that many of you have already used. They have application programming interfaces, an API. You can basically write a program, a wrapper around one of these APIs in a weekend. Each individual request is pennies per request. And not only are they cloud-based, but also on device, so on your phone, on your computer. What that means is a lot more flexibility in using it with patient data because you're not sending things to a third party that you don't have a BAA with. There are also increasingly HIPAA-compliant versions that many enterprises have enabled. So what are you going to do as an AI investigator or as an end user? Well, as an investigator, you can certainly train models. You're probably just going to be optimizing large language models unless you have a handy nuclear reactor. You're also potentially going to be using traditional machine learning models. That's definitely within our scope. But realistically, most of us are going to be using models. So whether you're evaluating model performance or real-world impact, or in your day-to-day life as a clinician. So what are the opportunities in clinical care? These are not specific to sexual medicine, but I think this is where all of us are going to see these first. Documentation and AI scribes, secure messages and communication, symptom triage and chatbots, patient education, which can be customized to each patient's individual medical record. A lot of effort being placed into back office automation. The others, I think, are a little bit less relevant in sex med. But I think we always have to realize what are the risks of being wrong when you implement one of these models, when we think about the use cases. Is there a human in the loop? And is this a circumstance in which you want random variation or not? And how is this actually going to integrate with your workflow, okay, when you're seeing patients? You don't want something that's going to massively slow you down. It's also going to depend on your specific practice setting. So if you're employed or part of a large enterprise, your first exposure to most of these tools is going to be something that's integrated into your electronic health record system. You may be more insulated from the direct costs, and you also may have less individual choice for which vendor or which tool you use. If you're in a smaller practice where you have a little bit more control, you have more flexibility in vendor selection, but you have more direct exposure to the cost and potentially the benefits as well, and you may be more reliant on the vendor for support. I think one of the key things in SexMed is this huge business-to-consumer effect. So it's a massive industry. I don't know the number, but I know it's very large. Everyone, every article you find just has a bigger and bigger number. And there are lots of companies that target to patients that are using these tools in the back end. These don't need to be FDA approved and can pop up over a weekend. So let's talk a little bit about AI scribes, because that's probably where most of you are going to see this first. Kaiser had a quote-unquote pilot, and I put that in quotes because during the 10-week program, they onboarded 3,000 physicians to their program, so it seems more like an implementation than a pilot. But what they found is physicians that were using AI scribes spent less time in notes per appointment. There was no change in how much time they spent ordering things, reviewing records, or in the in-basket, but less time in notes. At UCSF, we've rolled this out with about 160 users, and we find that there's less time spent in notes, but also decreased cognitive impact. So 90% of the physicians said they wanted to continue using scribes. There was a 23% increase in physicians who felt that their ambulatory workload just felt sustainable. Overall, there was about a 10% increase in the number of visits closed same day. And you can see decreased time in documentation, instructions, minimal impact in total time in the EHR, and a small impact in work outside of clinic hours. We're also looking at using AI to generate draft messages to patients. A lot of your time is probably spent in the in-basket responding to patient requests. And these tools are coming, they're integrated into Epic. You may already have them at your organization, or your organization may be thinking about rolling them out. And it basically uses the patient's message and drafts a response to them. You can review the draft, and you can say if you want to start with it or you want to start with a blank reply. There have been a few randomized trials looking at this, and the physicians spent more time reading messages. The replies were longer, but there was no overall change in reply time. Okay? And anyone that's used one of these tools, you can see that you get quite a lengthy response from one of these tools. There's another randomized trial looking at various physicians and providers and pharmacists' experience with this, and there's no change in time with read, write, or reply time, but there was a decrease in burnout score and a decrease in task load score. We all know anyone that sent us a manuscript to review, it's much easier to revise a manuscript than it is to start from a blank page. This is also really interesting. Both patients and physicians felt that the AI-generated tools were more empathetic. And they actually felt that the AI-generated messages were higher quality than the ones generated by physicians. So Epic has a lot of tools that are going to roll out. Cerner maybe a little bit less. And I'm just going to highlight a few things which I think may be relevant to many of you as investigators. There's something called the Cognitive Computing Platform, and the key here is it's going to allow you to develop your own AI algorithms and implement them in Epic for your patients. There's going to be some transparency around why it's making the recommendations that it's making, and these models can also be shared with investigators if you're looking at doing a multi-institutional trial. Within the tool, it'll show you, based on the algorithm that you've developed or deployed, why it's making the recommendation and what factors are contributing to that, and how the change happens over time. There's tons of predictive models coming from Epic, but for the most part, they focus on inpatient care. Fewer of them are going to focus on sexual medicine and ambulatory care. But there are tools to summarize notes before a visit, opportunities to recommend codes from your clinical notes. So if you did something but you didn't know or think to code for it, it may recommend that for you. And this is just a huge metric of the additional tools that are coming or already underway. So when we talk about generative AI in clinical care, it's here. Many people are already using it. I think the impacts are very variable. You may have some unintended consequences. It may not work out the way you think, but it will be integrated into your EHR workflow. And some of the key barriers are trust, both physicians and providers with the tools, patients with the tools, and of the results that you get. Technical integration, which can be challenging, and workflow integration, which I think is the most important. And I'll just end with saying that AI will never be as bad as it is today. So thank you.